All right, Friday, March 20th, 2020. Mr. Trutna here. This is Unit 11, Worksheet number 2. So our objectives today, this is what we're going to go over, and the work we're going to go over is going to coincide with Worksheet number 2. So we're going to learn, our objectives are going to be, we're going to be writing equations in vertex form. They're going to be not given to you in vertex form. We're going to find the vertex. We're going to find the X-intercept or intercepts. Sometimes there's one X-intercept, sometimes there's two. We're going to find the Y-intercept, and notice that's singular. There's only one Y-intercept. And then we're going to sketch the graph, okay? And what we're going to do is we're going to go over 3 problems, and then hopefully that'll be enough to get you guys going on your work. So number 1, y is equal to x squared plus 12x plus 20. Okay, so if you notice, this particular equation is in standard form. All right, so the first thing that we want to do is we want to write it in vertex form. So how do we change an equation from standard form into vertex form? Remember, we're going to do the process which is called complete the square. Okay, so remember, so what we're going to do is this: you're going to write y equals, and then you're going to start a parentheses, and then you're going to take the x squared part, which we call the a part. Then you're going to take the plus 12x part, which is your b part, and you're going to put that in parentheses. Then you're going to put a plus, and then you're going to leave a gap here. So, and then you're going to close the parentheses. And then what is your c part, your plus 20, you're going to write on the outside of your equation here. Okay, so that's going to be your first step. And what we're going to do is, we are going to do that method called complete the square, and we're going to fill in a new c. So how do we do that? Well, remember, you take the b value, which in this case is positive 12. Then what you do is you divide it by 2. That gives you a result of 6. And then whatever that result is, you raise that result to the second power, or you square it. And whatever that equals, 6 to the second power is 36, make that your new c value. Okay, that method that we just did right there is called complete the square. Then, because I put a plus 36 inside the parentheses, outside the parentheses you're going to want to put a minus 36. Okay? All right, so then this is not in vertex form, but our next step is now we're going to factor this trinomial. So after we complete the square, then we're going to take this part right here inside the parentheses, and we're going to factor it. Okay, so how do you factor a trinomial? Remember, you have to think using the t-chart to factor. All right, so to factor the trinomial, I have to come up with all the distinct pairs of numbers that multiply to make 36. So 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. And one of these will be my factors if one of these distinct pairs, which multiply to make 36, will add to make positive 12. And you can see it's going to be 6 and 6. So what that means is that when I factor this, and I'm going to take this part here and I'm just going to move it a little bit further down right there, x squared plus 12x plus 36 would factor into quantity x plus 6, that's my first factor, positive 6, and then another quantity x plus 6. Okay, and then I would have positive 20 minus 36 becomes negative 16. So now my equation becomes y equals x plus 6 minus 16. Well, that's not in vertex form, but now we can put it in vertex form because I have 2 sets of x plus 6's. So that means I have x plus 6 to the second power minus 16. That is what we call vertex form. Okay, so in number 1 right here, so when now if I said what is the vertex, let's go ahead and answer it right here. So the vertex, this vertex form tells me, remember, your vertex is your h value and your k value in vertex form. So my vertex, since my h value is positive 6, you have to think opposite. That would be negative 6, negative 16. So that right there would be my vertex. Okay, so that's the first step. Write in vertex form. I just did that. So that would be like objective number 1. Right here, write in vertex form. Objective number 2, find the vertex. We just did that. Now objective number 3 is going to be, now we're going to find the x-intercepts. Okay, so here's how you find the x-intercepts, and I'll kind of denote it over here. Finding the x-intercept. There may just be one, or there actually could be two. Okay, so we'll put x-intercept or x-intercepts. Okay, so how do we do this? Well, here's what you do. You're going to take this equation right here that you got in vertex form, and all you do is you change the y into 0. Okay, so what we're going to do is, to find the x-intercepts, we change the y value into 0. Then we get equals quantity x plus 6 squared minus 16, and then I'm going to solve this equation for x. Okay, and whatever my answers are for x, that's going to be my answer to number 3. That's going to be my x-intercepts. Okay, so how do I solve? Let's go down here. How do I solve this equation for x? I need to isolate the x. So my first step would be to subtract 16 from both sides of the equation, or add, 16 to both sides of the equation. Okay, when I do that, after these 16s cancel out, then my new equation is going to become positive 16 is equal to quantity x plus 6 to the second power. Okay, now I need to isolate the x. So if you recall, what I'm going to do next is I need to eliminate the second power. So the way that you eliminate, I'm going to pull this up a little bit. The way you eliminate the second power is you're going to take the square root of both sides of the equation. We did this. This is what you were doing earlier in the worksheet when you were solving for x. So that second power would cancel out the square root, and then my equation would become the square root of 16 is 4. But remember, it's not just 4, it's positive 4 and negative 4, and then that would be equal to x plus 6, and we could drop the parentheses. My next step to solve, to isolate the x's, is I would subtract 6 from both sides of the equation, and after the 6's cancel each other out, we would get x is equal to, now remember, now we're going to have two answers for x. We're going to have positive 4 minus 6, and then our other answer is going to be negative 4 minus 6. So x is going to be negative 2, x is also going to be negative 10. Okay, so x is equal to negative 2 comma negative 10. All right, so and those, whatever those answers turn out to be, when you solve it for x, those are your x-intercepts. So your x-intercepts are and they're going to be coordinates. It's going to be negative 2 comma 0, and your other x-intercept is going to be the point negative 10 comma 0. Okay, and the reason for that is, remember, the x-intercepts are where your graph crosses the x-axis. Okay, so now we're almost done, but remember, our fourth objective is we're going to find now the y-intercept. Okay, so how do we find the y-intercept? Well, to find the y-intercept, this is what you do. All right, and we'll put this over here. So number 4, we're going to find the y-intercept. Okay, so to find the y-intercept, and then I'll make a note right up here, finding the y-intercept, and this is going to be a lot of information, and so as you guys do these problems, just kind of follow the process and hopefully you get it. So when we find the y-intercept, what we're going to do is you're going to go back to your original equation, okay, which is y is equal to x squared plus 12x plus 20, and to find the y-intercept, what you do is you change all the x's into 0. So I get y equals 0 to the second power plus 12 times 0 plus 20, and you work that out, and whatever y equals, that's going to be your y-intercept, okay? So what is this? Well, this is positive 20. So y is equal to positive 20. So in number 3, what's my y-intercept? My y-intercept would be the coordinate of the point 0, 20, okay? All right, so then objective number 5 is, now we're going to sketch the graph of what this parabola looks like, okay? So we're going to sketch the graph. And what we're going to do is what we've allowed ourselves to do, because we have found the x-intercept, and we found the y-intercept, and we found the vertex, what we've allowed ourselves to do now is we can now sketch the parabola that we're going to get from this quadratic without having to make a table at all. Okay, so what I'm going to do is I'm going to go ahead and I'm going to scale this graph out. 1, 2, 3, 4, -5, 6, 7, 8, 9. I'm going to go out to -10. And then on the y-axis, I'm going to scale by 5s, I think. So I'm going to go, let's see, positive 5, positive 10, positive 15, positive 20, and then -5, -10, -15, -20. Okay, and then I guess I could do this too. I'm really not going to need the positive. Okay, so now let's plot these points. So the first point I'm going to plot is the vertex, the point -6, -16. So left 6 down to about where 16 is. And if we were doing this on graph paper, this would be way more accurate, but I'm just guessing, okay? So there's your vertex, -6, -16. Then you're going to plot the two x-intercepts, -2, 0, right there. Okay, so there's -2, 0, and -10, 0. So there's your other x-intercept, -10, 0. And notice the y value for your x-intercepts will always be 0, because the x-intercept is going to be where your graph is going to cross the x-axis. And then your y-intercept is over 0 up 20. So your y-intercept is right there at over 0 up 20. Okay? And those are the points that you're going to use. So now when you graph it, just connect all of these points in a nice, smooth curve. Make it a U if you can. Don't make it a V. Okay, and there we go. Now you can see, since a parabola here, and I didn't quite graph it perfectly, but since a parabola is a mirror image of itself on both sides of, remember we called this the line or the axis of symmetry, what you could do is you could then mirror this point over here, and that would then give you, you could extend it up. Okay, so that would be how you're going to be doing. Make sure to put arrows at the end. So those are all the steps that you're going to be doing in these problems. Okay, all right, so let's do 2 more. That took me 13 minutes to do 1 problem. So hopefully we could get through these other problems a little bit faster. All right, this is probably the most intense thing that we've done in a while, as far as like the number of steps that we have. Okay, so my next one is y equals x squared plus 4x minus 5. So y equals x squared plus 4x minus 5. So remember, I have a couple of things that I want. I want to know, I want vertex form. So I'm going to change this into vertex form. I want to know what are the coordinates of the vertex. I want to know the x-intercept or x-intercepts. There might be 1, there might be 2, and then I want to know the y-intercept, and then we're going to use all of this in order to graph. Okay? All right, so here's how we do it. So we take our equation, y equals, remember you start at parentheses, put the x squared part, put the plus 4x part in the parentheses, put a plus, and then you're going to leave a gap right here. I always put a line there, you don't have to. Put a gap. And then your c value, -5, put it on the outside, and now inside of the parentheses, we are going to complete the square. This is the process we do to change this form, standard form, into vertex form. So I take my b value, which is +4, I divide it by 2, That gives me a result of 2. Then you take that result and you square it, and whatever that equals, that's your new C value, positive 4. Since I put a positive 4 inside of the parentheses, I have to balance the equation out and put a negative 4 outside of the parentheses, okay? So now this right here is, this is going to be by completing the square, okay? So now my next step is I'm going to factor this, all right? And this is where there is a definite shortcut on how to factor. So if you know the shortcut, go ahead and do it. But, so when I factor this, I'm going to get this trinomial. I'm going to get y equals, and then I'm going to have 2 sets of parentheses. Outside the parentheses, I'm going to have a negative 9, because minus 5 minus 4 is negative 9. So let's factor this trinomial. Okay, so I'm going to make my t-chart. I'm going to take my C value, which is positive 4, and I'm going to write down all the distinct pairs of numbers that multiply to 4. There's only 2. Which one of those add to make your B value positive 4? Okay, well, it would be 2 and 2. So my 2 factors are y equals x plus 2 and x plus 2. That is not quite in vertex form yet, but I have 2 sets of x plus 2, so I get y equals x plus 2 to the second power minus 9, okay? Excuse me. And if you notice, the shortcut is these 2 numbers right here are always the same when we do that complete the square method, and those 2 numbers are whatever that is right there. Okay, so that's a shortcut, so you could avoid having to do all the t-chart and stuff like that. So my vertex form is y is equal to quantity x plus 2 to the second power minus 9. That form tells me what my vertex is. So my vertex is always my h value and my k value, but it's the opposite for h. So it'd be negative 2, because there's a positive 2 there, and then negative 9. So there's my vertex, okay? So that would be the first step, putting it in vertex form. Hopefully you guys get that. Then my next step is finding the x-intercepts. Okay, so how do we find the x-intercepts? Remember, the step is you take your equation right here, this y equals, but to find the x-intercepts, all you do is you make y equal to 0. So your equation would become, instead of y equals, it becomes 0 equals quantity x plus 2 to the second power minus 9, and then to find my x-intercepts, I solve this equation out, and I'm going to use square roots to get my answer. When I solve it for x, that would give me my x-intercepts. So my first step to solve this equation is I'm going to add 9 to both sides of the equation. I have to isolate the x. After these 9's cancel each other out, I get a new equation. It would be 9 is equal to quantity x plus 2 to the second power. Now, I don't have my x isolated yet. I need to get rid of the power of 2. So what's the opposite math operation of the power of 2? It's the square root. So I'm going to square root both sides of the equation. That power of 2 would cancel out the square root symbol. So now they're gone. The square root of 9 is 3, but it's positive or negative 3, and that would be equal to x plus 2, and you could get rid of the parentheses. Now to isolate the x, I would do the opposite math operation of plus 2, so I would subtract 2 from both sides of the equation. Okay, so after these 2's cancel out, I would get x is equal to, and now remember, you're going to end up with 2 answers here. One of your answers will be positive 3 minus 2. Well, that's equal to 1. And then your other answer will be negative 3 minus 2. That's equal to negative 5. So we get x is equal to negative 5, comma 1. Those 2 answers right there, those are your x-intercepts. Okay? So how do you write the x-intercepts? You write them as an ordered pair, And the ordered pair would be -5, 0, and your other x-intercept would be +1, 0. For the x-intercepts, because they're going to be crossing the x-axis, your y value is always 0. Okay? Then your next step is going to be to find, so that would be how we find the x-intercepts. Your next step is, now we're going to find the y-intercept. Okay, and there's only going to be one y-intercept when you do this. So how do you find the y-intercept? Remember, you go back to your original equation in standard form. This is the easiest way to find your y-intercept. And what you do is you change all of the x's to equal 0. So instead of y equals x squared plus 4x minus 5, you change all the x's to 0, so you would get y equals 0 squared plus 4 times 0, and it looks like my pen just ran out of ink at the most inopportune time ever. Fortunately, I have a backup. There we go. Minus 5. And whatever this equals, that's your y-intercept. So 0 squared is 0, 4 times 0 is 0, so we would get y is equal to -5. Okay, so this answer right here, that is your y-intercept. Okay, and then to write your y-intercept, you write it as an ordered pair, and it would be the ordered pair 0, -5, whatever that number is. Your x value for your y-intercept is always 0. So there's your y-intercept. There we go. Okay, so then my last step is I'm going to make a graph of this of these points, so I could get an idea of what my parabola looks like after I figure all this out. Okay, so I'm going to go ahead and I'm going to draw a y-axis. I'm going to draw an x-axis, and it looks like I have mostly negative numbers, so I'm going to kind of offset my x-axis up here, y-axis, and then I only have to go out, so I should have offset my y-axis way over here, but oh well. 1, 2, 3, 4, -5. I only have to go out to -5. I'll go out a couple spaces to the positive, but I don't think I'll need them. And then it looks like I'll have to go down to -9. So I'll go by ones. 1, 2, 3, 4. There's -5, 6, 7, 8, -9. And then what I'm going to do is I'm going to plot the vertex, -2, -9, which is left 2, down 9. So that would be right there. There's my vertex. -2, -9. Whoops, you can barely see it, but I got to try to fit it all on the graph there. That's a -9. Then I'm going to plot my two x-intercepts, -5, 0, which is left 5 over 0. And then I'm going to plot left +1 over 0. There's my two x-intercepts right there. Okay, notice this is 1, 0, and that point is -5, 0. Then I'm going to plot my y-intercept, which is 0, -5, right there. So there's my y-intercept, 0, -5. And then I'm going to connect all the 1, 2, 3, 4 points, and I'm going to connect them in a nice, hopefully smooth U, and this will give me an idea of what my parabola looks like. Don't just connect dot to dot to dot to dot, as I like to say. Just extend your parabola a little bit past each one. Okay, and then if you really want to get fancy, not necessary, but remember a parabola is a mirror image of itself. So we would have this line going right through the middle, which we call the line or the axis of symmetry. It'll go right through your vertex. And so if you want to, you could put another point over here that mirrors the y-intercept over there, okay? And that would be an example of how to do the vertex form, vertex, x-intercept, y-intercept. Use that to get my graph, okay? All right, one more to go here, number 3. Sorry for being long-winded, but I feel like this is a lot of information that we're going to do. Okay, so I wish I could pause it for a second. That would save us some time. Remember, you could always watch these in time and a half speed also if you start getting the gist of how to do it. So y equals x squared plus 12x plus 35. Y equals x squared plus 12x plus 35. So here's what we're going to do again. We're going to put this standard form of a quadratic, we're going to convert it or change it into vertex form. Then we're going to state what the vertex is. Then we're going to find the x-intercept, or it might even be intercepts. And then then we're going to find the y-intercept. And then lastly, we will use the vertex, the x-intercept, the y-intercept to graph. Okay? All right, so the first thing, let's convert this into vertex form. All right, so remember, we go y equals, this is how we do it. We start a parentheses, you put the x squared, you put the 12x part in the parentheses, put a plus, and then you're going to leave a gap here. We're going to come up with a new c value. Close the parentheses. Whatever your c value is, which in this case is positive 35, put it outside the parentheses. Okay, so now we're going to complete the square. So we're going to take the b value, which is 12. We're going to divide it by 2, get that result, which is 6. Then square that result, 36, and whatever that is, you put right there. Now, I've been noticing on some of you guys' work, you're putting a 6 right here. Remember, you have to, once you divide it by 2, you have to square it. Then whatever that is, you put right there. Then, since I put a plus 36 inside for my new c, I have to put a minus 36 outside to balance the 2 out. Basically, I'm zeroing them out. Okay? So now what do I do? If you were in class right now, somebody would raise their hand and they would say, oh, Mr. Trutna, you factor now. Okay, go ahead and factor. And we're going to do the shortcut. So when I factor this, I'm going to get y equals, and then I'm going to have 2 sets of parentheses. So what's going to go in the parentheses? It's whatever that number is twice, because I did complete the square. So I'm going to get x plus 6 and x plus 6. Then outside, positive 35 minus 36 is negative 1. So that means I have 2 sets of x plus 6's, and I write it like that, minus 1. There you go. That is my vertex form. Y equals quantity x plus 6 to the second power minus 1. So remember, that gives me my h value of positive 6, my k value of negative 1. So now the vertex form tells me my vertex. It would be the opposite of what you see here. So that would be negative 6, comma, negative 1. All right, notice both of them are not opposite. The only opposite one is your h value that you put there. Okay, so that's all of that right there. That's how we put an equation from standard form into vertex form. Okay, so and that gave me both of these answers right there. So next I'm going to find my x-intercepts. Okay, and there could be 1, there could be 2. Okay, so how do I do that? Remember, I take my equation in vertex form right here, and I just make y equal to 0. Okay. So my equation would become 0 instead of y equals quantity x plus 6 to the second power minus 1. And I solve this equation for x by isolating the x. So I'm going to add 1 to both sides of the equation. After the 1's cancel out, my new equation becomes 0 plus 1. So that's 1 is equal to quantity x plus 6 to the second power. Then my next step is, remember, I'm trying to isolate the x. I need to get rid of that power of 2. So to do that, I do the opposite math operation of the power of 2, which is the square root. So I'm going to take the square root of both sides of the equation. That power of 2 would cancel out that square root. So now what's the square root of 1? Well, remember, that's just 1. But it's positive or negative 1. Okay, 1 times 1 is 1, but it's also negative 1 times negative 1 is also 1. So that's why I get positive or negative 1. Over here I have x plus 6. Okay, now I need to still isolate the x to solve for x. So I'm going to subtract 6 from both sides of the equation. Those 6's would cancel, and then I'm going to get x is equal to, and now at this point I'm going to get two answers. I'm going to get positive 1 minus 6, which is negative 5, and then I'm going to get negative 1 minus 6, which is negative 7. So my two answers are x equals negative 7 and negative 5, and remember, those two answers are your x-intercepts. Okay, so but when you write your x-intercepts, you write them as an ordered pair. So my x-intercepts would be the ordered pair, negative 7 comma 0, and my other one would be the ordered pair, negative 5 comma 0. And the reason why the y value is 0 for the x-intercepts, that's because the y value will always be 0 right on the x-axis of a graph. Okay, then my last step is, now I'm going to find my y-intercept. All right, so what's the easiest way probably to find the y-intercept? What you do is you go back to your original equation in standard form. Okay, there's a lot of lines going around here. And what you do when you find your y-intercept is you make x equal to 0. So your original equation in standard form is y equals x to the second power plus 12x plus 35. Change all the x's to 0, and whatever that equals, that is your y-intercept. Okay, and you can see, since that would be 0, and since that would be 0, we will get y is equal to 35. That's my y-intercept. Okay, so whatever you get right here, boom, that's your y-intercept. So your y-intercept, write it as an ordered pair. It's always, the x value is 0 for the y-intercept, and then it would be 35. Okay? And then what I'm going to do is, lastly, I'm going to use all of these right here, all these coordinates, and I'm going to use that to create my graph of my parabola. Okay, so I'm going to draw my two axes. And on your assignment, on your paper, the axes will already be drawn for you. They're not on graph paper, but at least the axes will already be drawn for you. You have to figure out how to scale it. Okay, so if you notice, I need to go all the way up to positive 35. And then I only have negative values on for my x, so I should have just shifted my whole y-axis over here. Okay, but I didn't. But I do have to go up to positive 35. So I'm going to scale my y-axis by 5s. 5, 10, 15, 20, 25, 30, 35. And then I'm going to scale my x-axis just by 1s. So, and I got to go out to negative 7. 1, 2, 3, 4, 5, 6, 7. So there's negative 7. 1, 2, 3, 4, there's negative 5. Okay, I'll do my, just for fun, I'll do that. Don't really have to. Okay, so let's plot the points. The vertex is negative 6, negative 1. So that means left 6, down 1. Now don't go all the way down here because remember I'm going by 5s. So left 6, down 1 would be about right there. Okay, so that would be negative 6, negative 1. My x-intercept, one of them is negative 7, 0, right there. My other x-intercept is negative 5, 0, right there. And then my y-intercept is 0, 35, so that would be way up here. Okay, so this is going to look kind of weird, so then I connect the 3 points in a smooth, hopefully U-shaped graph, which we call a parabola, and this one's going to shoot off way over here like this and extend it up. Okay, then remember, because a parabola is a mirror image of itself, so we have this line called the line of symmetry that's going to go right through your vertex. So that means we could take that point and we could transpose it on the other side of the graph, and I'm just going to estimate where it is. Let's say about right, I don't know, maybe there. And then I could extend this up like that to kind of give it a better look. I don't know if that helped much. Very ugly graph, but there we go. Okay, hey, 34 minutes later, we're done.